these are the notes with step-by-step guide of how we are supposed to create this web app. So it includes all the codes that you will need for today. So I'll share this with you. And then apart from that, this is what we are basically creating. So it's a breast cancer survival prediction web app. It's running on my PC. So you can see this is localhost, something that I haven't taught you. So because I believe you creating apps that are running online on the go is the best way to go. And maybe I can take you through a quick overview of what we are creating. So we've got patient's information. So this is a form where you're supposed to input patient's information. We can load random sample patient, and you can see it autofills this form with random patient information. What you can do again is you can type in or pick any values that you think are relevant for that given patient. So this is the other option. And then once you've done that, you can click predict survival. It will give you the prediction. So this patient most probably will be alive in the next checkup. And then what is the confidence level? So the confidence level is 62.37%. And then over here, we've got a small plot showing you the mortality risk. So if you are a doctor, you might look at this plot and decide what you're supposed to do with this patient. Does he need uh, urgent care or things like that? And then down here, you've got an analysis of future importance. So this is what we did in our notebook. We saw that survival month was the most important feature. And then over here, we've got explainability of the model. Like what are the contribution of the different variables that we have in this data to this mortality risk or this prediction that is this individual is alive. So you can see if we increase the number of months to something like 100 and maybe predict survival, this person is alive for, and you can see the number of survival month is green, meaning that it has contributed to this guy not being at risk. If we reduce this to 20, let's say 10 or 2, predict survival, let me reduce this. Predict survival, you can see the risk increases. So this person is dead with a 53% chance. And what was the main contributor? It was the number of survival months. So that's what we are basically creating. So let's load two other samples and see what we get. So this guy is alive. And this is the explanation of why this guy is alive. Let's load another sample. Then predict survival. So this guy is alive as well. And you can see what are the top contributors of this guy being alive. So you can see it's no longer survival months, but the number of node ratio. So that's basically what you'll need to look at when creating your model. So this is something I believe you were not taught in class, but you get to learn these things when you interact with this online. We've got the about page. So this is all about the project. We've got the information page, all the information concerning this project, and some key factors affecting survival rates. So we've got tumor size, and we've got all these other features. We've got some basic EDA. Here we've got survival rates for different races, survival rate for estrogen level, survival rate for so this plot is not that, it's not fitted that great, so this is something you can improve on. Okay, but down here you can see at least these, the y-axis tells you what we are looking at. So for example, this is the plot for race, this is the plot for uh, estrogen levels, this is the plot for race again. So these are some of the things that we are supposed to fix. And then over here we can see, like, from EDA, the survival rate by tumor size. So you can see the survival rate keeps on reducing by the size of the tumor that you have. So these are some of the things that you'll need to implement into your EDA. And then lastly, we've got the prediction tab. So all this analysis was done on Colab. This is the Colab notebook with all the analysis. So I basically improved what we did last time, and this is what we have. So in the next 3 minutes, let me take you through what we have. So we've got comprehensive data exploration, because I believe we did not cover this whole thing in our class. We've got feature engineering, fitting of multiple machine learning models with proper evaluation to compare. Then dealing with class imbalance, so I added that for you. And then lastly, we've got model interpretation and insight. So over here, we've got importation of libraries. So these are all the libraries that we will need. So these are the basic libraries. These are the xsklearn libraries. These are the models that we will fit. These are the evaluation metrics. And then these are what I used for imbalancing. And then this is what I used for model interpretation. I loaded the data just as we usually do, printed some basic statistics for the data, uh, checked for duplicates and deleted duplicates, checked for missing values and removed the missing values. And then here we've got the check for outliers. So this gave me an error, so I left it as it is. Then I went ahead and created box plots for all the variables that we had, just to check for outliers. So this is something that we did with just a sample. But over here, I've plotted a box plot for all the variables that we have in the data. And then after that, we've got the target variable analysis. So over here in the target variable analysis, we start by looking at the distribution of the survival status. So those who are alive are 84.7%, those who are dead are 15.3%. And then we've got deeper EDA, so summary statistics for each numeric column, and then the distribution of survival status for each categorical column. I guess in Colab, not everything is showing. Let me show you this from my code, because I ran everything on my local PC. Yeah, so this should be better. Okay, so this is the distribution of survival status. This is the distribution of age by survival status. So a histogram plus a box plot to show you what the distribution is. Then this is the correlation matrix to show you what are the different correlations that you have with your variables. Then tumor size versus survival. So remember we did a violin plot. So over here I've added a box plot for the same. Then we've got a look at the distribution of estrogen and survival status. So we are looking basically at the count and the percentage. Same for progesterone, count and percentage. And then we've got 6 stages, count and percentage for the same. These an analysis of survival by grade, so count and percentage as well. Raise count and percentage, so that's what we have over there. And then we look at the survival month. So these are the individuals who are dead based off the survival month. This analysis looks a little bit better, so you can see for those who are at a lower month, they have a lower chance of survival, and then those who are at 50 and above have a high chance of being alive. Then just a plot comparing all the different variables, and then we go ahead to feature engineering. So in feature engineering, here we create new columns if needed. So for example, the node feature and tumor size categories. So those are some of the new features that I've created. Then we've got feature selection and modeling. So I split the data into X and Y. We print everything that is there. We scale numerical features, and we impute missing values with the median. Then for categorical features, we impute them and we one-hot encode them. So over here, I'm not using ordinal encoder. And what I'm using over here is a pipeline. So it means I'll have to instantiate everything and then do a combined pre-processing for all the steps. So using transformers, okay? And you use column transformer to do this. So you'll inspect my code and have a look at what I've done and adapt this to any work that you will be doing before. Then we create our test and training data. Then here I'm defining the models that I'm going to fit. Remember, we only fitted a random forest model. So here I'll fit a logistic regression model, random forest model, XGBoost, SVM, and gradient boosting model. So those are the models that I fitted in this notebook. And then for better accuracy results, I did cross validation. Then the scoring metrics that I needed were accuracy, precision, recall F1 score, and the ROC AUC score. Then I create an evaluation function. If we So if I run that model, you can see the accuracy metrics for all the models that I've created. So logistic regression, 80%, random forest had 89%. And if we look at the ROC score, I guess, which is the best score to look at this task, ROC for logistic regression was 79%, for random forest 79, for actually it was at 68. Then for XGBoost 72, for SVM 76, for gradient boosting it was at 74. And then I went ahead and plotted the accuracy results for all the models. You can see if we look at accuracy, gradient boosting comes in at the top, then SVM is at the bottom. Looking at cross-validation results, these are the results. So logistic regression gives the lowest accuracy for cross-validation, and random forest gives the best accuracy. For cross-validation on recall comparison, logistic regression gives the best results, followed by SVM. So I'll skip that, and then over here we've got a table showing you the different accuracy scores. So if we have a look at everything that we have over here, gradient boosting was at the top in terms of accuracy, and the F1 score. So it had an F1 score of 0.62. And I picked this model. And before I picked that model, I went ahead and balanced the data set and refitted it to see if it will give me the best results. And then I went ahead and did hyperparameter tuning for gradient boosting. You can check that. And then lastly, I evaluated the model for XGBoost. And those were the results. And this is the results for the ROC curve and the AUC score for the same. Then I went ahead and plotted feature importance. And lastly, I explained the model, like what do these features contribute to this model. And lastly, I extracted the model, and this model, we are going to use it for this class, and did some predictions. So we've got the actual status versus the predicted status and the probability of death. So from this notebook, what we are mostly interested in is the model. So I've saved the model online. So the model is available in the notes over here. You can click on it once and download it, because this is what we are going to use. So let me share this link with you again for those who have joined us late, and then we can start actually creating the web app. So I've taken you through the notebook. It's available on this link. I'll upload it as an IPYNB file over here as well. But let's begin the code work. So I'll head over to streamlit.io. I'll log in. So log in with GitHub. And then what I'm going to do is I'm going to create a new app. Then for this new app, I'll deploy a public app from a template. Then we'll have a blank template. And then for the repo name, it's cancer prediction. Cancer prediction web. And then here I'll need to add a URL for my web app. Cancer prediction. Web, and then here I'll have cancer prediction. Okay, I'll have this as my domain name. Then I'll open GitHub Codespaces to immediately edit this up in my browser. So you can do that as well, and we can proceed on in the next 3 minutes. So I'll give you 3 minutes to set this up and head over to Notion and download this model that we have over here. So you can download this model as we are proceeding on with the creation of the front end. And yeah, I'll show you how you can integrate it to your front end as we are proceeding on. So I'll click deploy and we'll wait for Codespaces to open, and as my Codespaces is opening, you'll have time to open the notes, download the model, and also set up your Streamlit as well. My web app is ready. I'll give you 2 extra minutes to set yours up as well, and then we can proceed. Okay, let's begin. So the first and most important thing is to set up your environment. I don't know if I've pasted the requirements over here. We've got the libraries, but I've not pasted the requirements. So we can type them ourselves. So we will start by editing the requirements.txt file. And for the requirements.txt file, we need to include all the libraries that we are going to work with. So we'll need pandas, we'll need NumPy, and kindly ensure that the spelling for these libraries are correct. Then we'll need matplotlib. What else will we need? Let me activate GitHub Copilot because this will actually help ensure that what I'm typing over here is correct. So I'll go to extensions and then I'll search for GitHub Copilot. You can install GitHub Copilot. I believe I shared a tutorial on this in another session. So mine has been installed and it's running. I can proceed. So we've got matplotlib, we've got Seaborn, we've got scikit-learn, we've got Sharp, we've got XGBoost. We'll need Plotly. Another library that we'll need is Pillow for model loading. And lastly, we will need Streamlit. We'll need Streamlit Sharp. So this is for model explainability on Streamlit. Let me copy this and share it with you in the chat. So Edith, I see you're asking how do you download these files. So this is your model. So if you open these notes, so let me open a new private window. If you open those notes on a new private window, I guess you won't be logged into Notion. What you do is, do you see the breast underscore cancer underscore prediction model.pkl? You just click on that once and the download should start. So save this in your downloads folder and yeah. So you'll save this in your downloads folder and then you'll come back over here to where we have our Streamlit code. Click on files and then open your downloads folder and then drag and drop that model file. So I have my model file uploaded over there. So that's how you basically do it. So I'll close that. So these are the requirements. I've shared them with you in the chat. So we should proceed. So for these requirements, some of them should be installed and we can confirm that right now. So on our streamlit underscore app.py file, we are going to make these imports for the libraries that we need, and then we will confirm which libraries have been installed into our space and which one are not. So I'll close this, I'll minimize this, and then I'll close this, and then we can start the actual coding. So we usually start with importing Streamlit. Then we will have import pandas as PD, import NumPy as NP. We will have import pickle, import pickle. Apart from pickle, we'll need matplotlib, so import matplotlib.pyplot as plt. We'll need Seaborn, we'll need Sharp, import Sharp. And then we'll need to import, so from pil import image. So that library, we won't use it in today's class, but you can use it to render the graphs that you have. Then we are going to import plotly.express as px, then plotly.graph objects as go, and then we are going to import model explainability from Streamlit. So import Streamlit we're going to have from Streamlit underscore sharp import st sharp. So those are the libraries that we'll need. If I have a look at what my terminal is telling me about the problems that we have over here, you can see we have 6 libraries that are missing. So I'll head over to my terminal. I'll open a new terminal and I'll start installing libraries that are missing up here. So we will start with matplotlib, or we can install Seaborn and see if Seaborn can install the matplotlib for us. So we will have pip install Seaborn. Another library that is missing is sharp, so we will have space sharp. Then space, we will have plotly. Then space, then we will have streamlit underscore sharp. So those are the libraries that are missing. Let me copy this installation command and share it with you. So you have that. And I guess in the notes, we have the code for doing that as well. So you can copy this. Let me actually copy what is in the code in the notes, and then I'll paste it here. So what is in the notes is for installation of all the libraries. I've pasted it there, so it should start the installation process. Okay, so my libraries have been imported. You can see we've got no problems. So we will start by setting up the page. And for page, we usually have the page title. So page title in this case will be breast cancer survival prediction. You can see the reason as to why I've enabled GitHub Copilot. It's actually typing in code for me first, so I can concentrate on changing things that I don't need over here. Then the next thing I'll need to add is an icon over here, so I can pick a doctor's icon here. So I'll pick that. Then layout, we can have a wide layout, and initial sidebar state. We can use an initial sidebar state that is expanded. So I'll click always rerun to see the changes that I'm doing over here and see if I've got any errors. Then I can open this in a new tab just to be able to see if there are any errors. So for you, you can copy what is in here directly and paste it to your work. But for me, I'll have to explain everything to you step by step, so that I'll be typing everything for you. But for you to make things easier, you can copy what is in the notes, so that I don't leave any one of you behind. Let me share the notes link with you again, just to confirm that everyone has access to what I'm teaching for today. That's the notes link. Let's proceed. So once we've set up our page, we'll need to set up some custom. So setup, we'll need to set up custom CSS for we'll need to set up custom CSS for the app, and we do this by typing in st.markdown. You open brackets. I'll close that bracket, and then we can start typing in things here. So we will start with the style. So this is actual CSS. So if you've learned something on HTML and CSS, this is actual CSS. We will start by customizing the main header. So we will have .main header. So this is for the main header of the page, okay? And for the main page of the page, what we specify first of all is the font size. So you can have a 2.5 font size. Then you can have the color. So for color, you can pick any color. So here we have E6 3946. So that is the color. Then we align the text in the center. So the text that will be printed in the web app will always be aligned to the center. And then margin bottom, you can have 20 pixels or 1 rem. So it all depends with what you're working with. Okay, so that's for the main header. I guess I'll have to add the triple quotation marks here. It's hidden. And here as well, and close them. I can basically copy what is here in the notes because this is just for styling, and it will take time to explain everything and type everything the go. So I'll paste what we have over there, and then I'll explain everything that we have over here. So this is for Markdown. What we set first of all is the main header. We set the font size, the color, the text align, and the margin. So what you can change over here is the color, have different colors or experiment with different colors. And this is a hex code. So we've got the RGB hex codes. And from the RGB hex codes, you can, where is it? Yeah, HTML color picker. So you can pick a hex code over here. So just play around with any and pick a brand color that you think aligns with what you are creating. Okay, so you can change these. So we've got the subheader text customization, we've got the info text customization, we've got the success box customization, we've got the warning box. So warning box is for any warnings that you will want. We've got the button customization, the button hover customization, then paragraph, H1 text, H2, H3 text customization, and then fields visibility. So those are the customizations that we've done in this app. So let's proceed. We now have our web app loaded. So the next thing we are going to do is we are going to load features that we'll need for this model. So we will use cache to save what the user has inputted so that they don't have to input everything afresh, or we don't have to rerun the database afresh, and this usually saves on the resources. So we will have st.cache data, and then we are going to create our function over here. So we are going to have def load underscore feature underscore info, and this is basically the function that is supposed to return information about features for the prediction form. Okay, so we add the triple quotation marks, and then we say this is supposed to return information about information about features for the prediction model. Okay, so that's what we are going to have, and then we are going to return, and the first thing that we return is age. And for age, we are going to specify the type. So type for age is a number. So age is a number. So I'll just do this one sample and then I'll copy the other from the notes just to explain what we are doing over here. So age, the type is a number. This is not supposed to be here. Then what is the minimum value for age? So minimum value for age should be, let's say you can have individuals starting from age 10 to age 100. And then the max age should be 100. And what is the default value? So default value, we can leave it. We don't really need it. So what we'll need to do is add a helper function. So help. So the helper function is there to guide a person on what they need to input. So over here, we'll say you'll need to input the age of the patient. Okay. And we'll say in years. So this is how we define the input forms. So I gave you an assignment on the different input widgets that we have in Streamlit. So if you had a look at that, you should be able to understand what I'm typing over here. So I'll head over to the notes and I'll copy these return function for all the other that we have over here. So we've got return, and then we've got all the values that we need. So we've got the return for age, res, marital status, T stage, N stage, 6 stage. We've got the differentiate. So all these are all the features that we are going to show the front end user. Okay, any questions up to that point? Anyone with a question? Okay, so once we've got that, there are features that I edited, or there are new features that I had created, and I'll have to copy that code from the notes because this is something that is available in our Jupyter notebooks. So I'll copy that and I'll explain what we have over here. So the next step is pre-processing of these input features. Okay, so I have defined the model over here, but I've actually not loaded the model. So we've got the pre-processing of features. So input df is equals to pd.dataframe, and then we get our input data. So input data will be created using this load feature info part. Okay, so we don't have input data yet. So this is an input that we will get from the user. And then we will convert this into our data frame and add missing columns. So for these missing columns, we will add a default value. I'll comment this out because this will actually be not missing, but T stage might be missing, but it's there in the input form. Okay, we've got the age group. So we've got the creation of age groups. So this is something that was fitted in the model, so it needs to be added over here. We've got the tumor size category. So this is something that was created when modeling, so it needs to be created as well. We've got the node ratio, we've got the node category, we've got the binary features from categorical columns, and age tumor interaction. And then this should return the pre-processed data frame for you. Once we've got that, the next thing will be to do predictions and visualizations. So over here, we will have the function to do predictions, and then we will have the function to display feature importance. So these are the two things that we'll need to add next. So I'll copy that and I'll add that to our Streamlit app and then discuss what we have over here. So we've got the function for getting prediction probability. So def get prediction probability, And for this, our input will be the model and the input df, okay? And this input df will be the preprocessed data frame that we have over here. So it's supposed to get predictions and probabilities. So our prediction will be equal to model.predict, then input df, then we get the first value. So this is the first sample value. And then we get the probability. So model probability should be equal to model.predict proba. So this is a function for getting probabilities for the model. And then the results should be equal to prediction. So dead if prediction is 1. So if prediction is equal to 1, then it means that we are supposed to display dead, else we are going to display alive. Then probability is we are going to get that probability over here. So probability, we extract the first value if prediction is equals to 1, else we just get the actual probability from the model. Then we save those variables in the variable probability alive and probability dead. Okay, then we return the results. So the results will be a dictionary. Then next we've got the display for feature importance. So this is supposed to display feature importance for the prediction model. So over here, what we are doing is we are using this library called as attribution. Okay, and for this we get the model and the name steps, and from that we extract the model coefficients, and from the model coefficients we get the feature importance. So it has got two ways of doing it. So it will use the dot feature importance method first, or it will use the dot coef method. So that's if we are using logistic regression, we can use the coefficients. If we are using random forest and all other models that have got this function enabled, it will use that. Then it will display and plot the feature importance for you after creating that data frame. So you can see we've got two different options. So we've got this first option for the basic models, and then we've got this model for tree-based models. So we are using if statements to just try everything out and avoid any errors. So if the model is a tree-based model, we can use the sharp values to visualize feature importance. So that's it for feature importance. Next, what we are going to look at is implementation of the EDA section. I can actually skip this because we don't need it that much. I'll copy it though. I'll paste it in the code, and this is something you can check out when you're free because it's a little bit long. And over here we are using Plotly curves. So the main part that we are discussing is the model deployment part. We've got this function over here called def generate random patient, and this is basically using the random library to create random features. Okay, we've got this part for generation of sample data. You can have a look at that. Display EDA. So EDA is basically everything that you've been doing. So for example, creating bar charts, but over here we are using Plotly. And next we've got user interactions. So for user interactions, we've got the main function. So I'll basically copy the main function, and then from the main function, we are going to now have our web app. I'll paste that there, and then I'll remove this. And now we can see if our web app is working. So we've got the load model not working. Let me change that in here. So there should be a part for where I'm supposed to specify the path of the model. Just a minute as I check which part it is, and then we can proceed. might have missed something. We've got load model. I guess it's working. Maybe let's click on this and come up with prediction. Yeah, so stats model is missing. I'll add this to requirements.txt, add it as well, and install it. And in a minute, I'll take you through this whole code again, because I believe we've just done copy pasting. Okay, so it's working. Let's check from here. This is working in dark mode. Let me edit the code, the course for you, and edit the last code part with the working code. So you can copy the whole thing and paste it to Streamlit, and then we can explain what we have. So that is the whole code. Though syntax highlighting has not been enabled. You can refresh the page and you'll have access to the updated code. So let me remove that, and then I can explain the code better over here. And we will start from the main function, because for the other functions I've explained a little bit. Let me close this. I believe we skipped this. So we've got the load model function. And for load model function, we've got this function with open. We open breastcancer.pkl file. So remember, we saved that in our root folder. So this is the path of the file. And we open the file with read permissions. And once we've done that, we save that in a variable called model. And model should be equal to pickle.load. And then we load our file. And that file has been opened using the with statement. And then we return the model. So this will be saved somewhere in a variable called model. So if this is not available, then we'll get an error. So for example, if I edit this and say model 3.4, if I open my app and click rerun, you can see it gives an error. Let me change the settings of this to be white mode. You can see we get an error, model file not found. Please make sure breast cancer underscore prediction is in the current directory. So if I remove the 34 that I had added and rerun, the error goes away. So that's how we load our model, okay? And then next we load our features. So I've explained what this is all about. Then we've got the pre-processing of input. So this is the creation of new features, similar to what we had in the Jupyter notebook for pre-processing. And then this is the function for probabilities, and then this is the function for feature importance. As I mentioned, I'll skip the generate random patient info part, because this is basically for just generating sample data. And I'll skip this as well because it's the same thing. We've got the part for displaying EDA visualizations. You know how EDA works. We've got EDA tab 1, EDA tab 2, and EDA tab 3. So we are just creating Plotly charts. So Plotly are interactive charts. You can replace this with Matplotlib or Seaborn charts. I'll skip that, and I'll head over to the main function, because this is where we have the main thing. So for the main function, first of all, we've got, if you have a look at our web app, we've got the prediction tab, EDA tab, information tab, and about tab. So how do we create these? So we create these using st.tabs. So we have tab 1, tab 2, tab 3, tab 4, and this will be equal to st.tabs. We've got the predictions tab, EDA tab, information tab, and about tab. And the tab that I'm going to talk about is tab 1, that is the predictions tab, because this is the main tab. For EDA, information, and about, if you have a look at what we have over here, EDA is just plots, information is just text, and about is just text. But our main tab over here is the predictions tab, because this is the tab that allows our user to interact with it and come up with predictions. So how do we come up to this? So in tab 1, we start by adding in our header. Then we load our model. So remember, we created our load model function, and I've shown you how the load model function works. Then next we load feature info. So load feature info, as I had mentioned earlier, is the function that creates this form that we have over here. If we have a look at it from the top, this is what we have. So it's supposed to get the age. So it specifies what the type of age is, number, minimum value, maximum value, and the helper function. So what does this helper function do? So if you come over here to the web app, you can see there is this question mark over here. So if our individual hovers over that question mark, they'll be able to see what that field is all about. So that's the helper function. So let's go back. So we load our features. Then we add a button over here. So this button is supposed to be the load random sample patient data. So that is the button that you are seeing over here. Okay. And what it does is it runs this generate random patient data function. And we've got that function over here, def generate random patient data. So we import random, and then we get the features that are there in the data, and then we populate them with random data. Okay, so we use the random library to do all this. Let's go back. Then after we've got the generated samples, the app is rerun, and we run this app to refresh the web form that we have. Okay, then we've got this form for getting user info. So we have with st.form, we've got key is equals to prediction form. So that is this form that you are seeing over here. And then we specified the columns that we'll need in this form. So you can see it has got 3 columns. So st.columns 3. Then we create an empty dictionary. And this empty dictionary is supposed to carry all the inputs that we'll get from the form. Okay. And we store these. We have these, if we have this stored session state, we use it. So if we have this data stored in our session, we use it, but if not, we get it from the data. So that's what we are doing over here. So for I in enumerate feature info.items, so we are getting the items that we had in our feature info. So this is the function that gets all the values that we have in our feature info, and then gets them from displays them in the front end and saves those values in their specified variables. And then lastly, we've got the submit button. So the submit button is supposed to do predictions once you've clicked it. So this is the form submit button that you have over there. So we have an if statement. So if submit button is clicked, then you pre-process the input data, then you get predictions. So when getting predictions, you are supposed to get predictions and their probabilities, and then you create 2 columns. So for column 1 is supposed to give you the prediction results, and then column 2 is the column that creates the gauge plot, and this is the code that creates the gauge code for you. And then we've got this other part that is for displaying feature importance. And then we've got, and for feature importance, we use the function that we had created earlier called display feature importance. And lastly, you display a warning disclaimer. So a warning disclaimer is just to tell individuals maybe not to trust what they are seeing and to always consult with their healthcare professionals. And then we've got tab 2, tab 3, and all that. So that's basically how we create these web app. So I'll save these and then I'll show you something. If for code spaces everything is working for you, then there is something I'll show you over here. Because I believe you guys are you've looked at the basic items that I've shared with you and you are okay with everything. What I'm going to show you is how you can easily create these Streamlit web apps from scratch. Okay, and you don't have to do this all on your own. You with availability of AI, you can basically control what is being displayed. So over here on GitHub Code Spaces, you've got Copilot. So the best model that you can work with is Cloud 3.7 Sonnet, but for the free models, you don't have access to it. So you can try create your web apps using these models that you have over here. So for example, I can click O3 Mini. I can add context to my streamlit.app file here, and then I can ask a question like create code with areas of improvement for my web app. Okay, so over here it will show you the existing code and it will share code for you with areas of improvement. So you can actually create your code using these models. So that is if you are starting from scratch. So the last thing that we are going to do for this class is commit changes. So this is our deployed app. And I'll click commit. I'll click yes. I'll sync changes. I'll click OK. I'll head over to Streamlit. I'll log in with GitHub. I'll check for the newly created web app here. Yeah, so this is the web app. And I'll confirm if everything is working on this end. So this is a link that I can share with you. You can check and confirm if everything is working. Yeah, so all libraries have been installed. We've got the form. I'll load sample patient data. Let me make this white mode. Load sample patient data and predict survival. So the deployed web app is working. So what I would suggest you do is using AI, have a look at what I've created over here and customize maybe the colors, the input form and everything, and share uh, share a link to your deployed web app with me. So don't stop at this what I've shown you for today. Use AI to customize the web app fully for you. And then on the WhatsApp group, share your final deployed web app, and then I'll share a comment on what you've done. So that should be it for me for today and for the model deployment class. I'm supposed to take you through the next unit that is on big data, though I won't do that for now. I'll consult with the team and see if they can give you access to a new trainer because I'm supposed to take my paternity leave as of today and I'll be back maybe on the 26th. So Yeah, that is it from me for today. I believe we can end the class at 9:30. I give you guys a chance to ask questions if you have any, or maybe comments from each one of you. Anyone with a comment, a suggestion, or anything they would like to say? Thank you, Edith. Anyone with a comment? Okay, I guess the silence means you are okay. Let me stop the class recording.